Hi, you guys. Welcome back. In this video, what we're going to talk about, we're going to continue on with descriptive statistics. So, what we spoke in class was we talked about the measures of central tendency, right? So, we said what they were, the mean, the median, and the mode. And we said kind of like this kind of just described what kind of the data looks like in the middle, right? How is each of these measures of central tendency affected when you have an outlier? What is the most typical value? So these are basically averages, right? So averages, ways that we describe the data. This is one way. And another way was variation, right? So we looked at the variation themselves. So we didn't really care about the data in the center. We cared more about how was the data varied? Was it really spread out, right? So if it was really spread out, right, it would look something like that, right? Whereas if it was very like, if the standard deviation or the measure of variation was very small, that means all the data were really close together, right? So that's what we talked about in class. So I also showed you guys how to do the standard deviation the long way, right? And I also showed you how to do it with the calculator way. So basically, all of these measures you can actually get from the calculator, right? Very simple. You can also use StatCrunch, but also doing it the old-fashioned way doesn't hurt when it's a small data set, but when you have really large data sets, it can get really scary, especially the standard deviation. Even if it's small or large, it's still going to be really a pain in the butt just to go ahead and figure it out by hand. So you have the calculator. Okay. So now, measures of location and relative standing. Now, what is that? So what this is, all it is just, it tells you the location of data values relative to others. Okay, that's what it is. I'm sorry, my writing is horrible because I'm writing on a touch screen. Okay, so location of data values relative to other data values. That's basically what it is. So where is this particular value? And the way that we can go ahead and describe it is one way with percentiles and quartiles. So most of you guys maybe have seen or have heard of a percentile. What does it mean to be the 30th percentile, for example? So if, let's say you have 30, let's say this is all the values, right? Let's assume these are all the values. If this was a 30th percentile, right? If this is a 30th, right? That means that 30% of the data points lie below it and 70% lie above it. That's basically just what a percentile is. So it separates the bottom percentage from the top 100 minus p percentage. So for example, let's say this was, let me give you a definition. Percentile. That way you can know what the heck I'm talking about. So it's just basically a number that divides the top p% from bottom. Oh man, no. The bottom p% from the top 100 minus p%. Okay, that's what it is. So it's a number. So this is a number. So the number is 30, right? So this 30 percentile is it divides the bottom p%, right? So here's the 30% from the top 100 minus p%. So 100 minus 30 gives me 70. That's basically the definition of a percentile. And that's all you basically need to know about it. When we talk about normal distribution and more continuous random variables later on when we get into the chapters, I'll explain a little bit of what a percentile really is like in the continuous case. So right now you don't really need to know much more about it. What I really want you guys to know, though, is what a quartile is, though. Okay, so a quartile actually is the same thing as a percentile. Okay, kind of. So a quartile, and I'll try my best not to mess up this time. A quartile basically separates the data into fourths. Okay, that's what it is. Okay, so if I were to go ahead and draw it, right? Let's say this is my data, right? Basically what the quartiles do, right? It separates everything into 25%. So everything is 25% evenly. Okay, so this is what it looks like. Okay, 25%, 25%, 25%. This will be the minimum value. This will be what we call Q1, and Q1 is just the first quartile. This is Q2, this is Q3, and this is the maximum value. Okay, so it's basically separating everything into 25%. Okay, now you might be asking yourself, how the heck do we calculate these numbers? Well, let's figure it out how we calculate them. All right, so let's do a very simple example. So let's say we had 1, 2, 3, 4, 1, 2, 3, 4, 5. I don't know. I made it up. Okay, so the first thing that we want to do when we find the quartiles, right? So if you look at my little diagram, you want to go ahead and order them first. So let's go ahead and order all of the data. So you're going to have 2 1s, right? 2 1s, 2 2s, 2 3s. This should be a 2. 2 3s, 2 4s, and 1 5. Okay, so that's what you have. Okay, so that's the first step. You're going to go ahead and order them. Okay, now Q2, actually, if you notice here, Q2 separates the bottom 50% from the top 50%. That's actually just the median, right? So basically, Q2 is the median. You can write that Q2 is actually the median. And in this case, it's just equal to 3. That's what Q2 is. Okay? Now, what is Q1 and what is Q3? So let's pretend that this one just went away. Okay? Q1 will be the median of the lower half. Okay? In this case, we have an even number of numbers, so we're going to take the middle 2, right? And take the average, right? I add them and divide by 2. Q1 in this case is equal to 1.5. So then in that case, Q3 would just be the middle number between 4 and 4. Well, in that case, Q3 will just be equal to 4. Exactly. So just like Q2 was just equal to the median, right? Another way, and if I wanted to talk about it in terms of percentiles, Q2 is actually also the 50th percentile. 50th percentile. Q1 will be the 25th percentile, and Q3 will be the 75th percentile, right? That's basically what it is. If I wanted to go ahead and call it name them in terms of percentiles. Okay, so, oops, sorry. Okay, so now, you'll see why this is useful, but right before I finish up, right, this is basically how you go ahead and find it. Now, if you had a larger data set, then this would be really, really annoying to go ahead and put it all in order. So what I'm going to go ahead and do,